Hello everyone, in this video I'm going to show how to use Gini index to identify the optimal splits for a decision tree. The Gini impurity index or the Gini index measures the degree of impurity of a set of cases in a multi-class classification content. Gini index is equal to 1 minus summation sign k is equal to 1 to m pk square, where pk is equal to total number of cases that belong to class k divided by total number of cases. For a binary classification problem, m is equal to 2, and the Gini index of a set of cases ranges from 0, which represents the highest purity, to 0.5 represents highest impurity. For example, if all the cases in the set belong to class 0 and none belongs to class 1, so 100% belongs to class 0, 0% belongs to class 1, the Gini index is 1 minus 1 squared plus 0 to the power 2, which is equal to 0. On the other hand, if half of the cases belongs to class 0 and the other half belongs to class 1, then the Gini index is 1 minus 0.5 to the power 2 plus 0.5 to the power 2, which equals to 0.5. As I mentioned earlier, we have the highest degree of impurity when half of the cases belong to one class and the other half belong to the other. With any other split, the Gini index will be less than 0.5. For example, let's say 90% belongs to class 0 and 10% belongs to class 1. Then the Gini index is 1 minus 0.9 to the power 2 plus 0.1 to the power 2 is equal to 0.18. This shows that it's relatively pure as its value closer to get 0, and it's impure if the Gini index value gets closer to 0.5. During the recursive partitioning process, the CART algorithm determines the optimal split at each step by comparing the Gini indexes for all possible splits across all variables. The optimal split is the one that produces the smallest Gini index. Now I'm going to show how to calculate Gini index for age variable and then income variable. Let's return to the HELOC example with the 20 randomly selected customers. Here on the figure, you see a plot of income against age. The 15 blue dots represent customers who didn't respond to the HELOC offer, whereas the 5 red dots represent customers who responded to the HELOC offer, class 1. Using this information, we can calculate the Gini index. 20 is going to be 1 minus 15 over 20 squared plus 5 over 20 squared, which is equal to 1 minus 0.5625 plus 0.0625, which is equal to 0.3750. This group of 20 cases is an impure subset, as 15 cases belong to class 0 and 5 cases belong to class 1, which is 75% to 25% split. Earlier, we calculate the possible split points for the age variable. One of the possible split is when age is equal to 49. Now you see on this figure a vertical black line at age 49, and the subset on the left includes all the cases whose ages are less than 49, and the subset on the right contains all the cases whose ages are greater than or equal to 49. Now we are going to use 49 split point to calculate Gini index. So let's start with the left subset, which in this case age is smaller than 49. We have total 16 cases and 2 of them are class 1 and the remaining 14 are class 0. For the right set, which is age greater than or equal to 49, we have 4 cases. 3 belongs to class 1 and 1 belongs to class 0. Now let's calculate the Gini index for the left branch. Gini for age less than 49 is equal to 1 minus 14 over 16 to the power 2 plus 2 over 16 to the power 2, which is equal to 0.2188. And now let's calculate Gini for this side. Gini age is greater than or equal to 49 equals to 1 minus 1 over 4 to the power 2 plus 3 over 4 to the power 2, which is equal to 0.3750. Now next we are going to compute the overall Gini index for the split. We use the weighted combination of the Gini indexes using the percentage of cases in each partition as the weight. So Gini is equal to, the weight for the left branch is 16 over 20 because there are 16 cases in the left branch, times the Gini index for the left branch, plus the weight for the right branch, which is 4 over 20, times 0.3750, the Gini for the right index, which is equal to 0.25. Partitioning the cases using an H split value of 49 has reduced the Gini index from 0.375 to 0.25. In our example, if you compute the Gini indexes for all possible splits for H, you will find that the split value of 49 produces the smallest Gini index. Therefore, this split is chosen as the best split for H. Next, we will continue to recursive partitioning process using the income variable. If you recall from the previous video, one of the possible split points on the income variable is when income is $64,500. In this figure, this horizontal black line splits the income at $64,500. This split creates top and bottom partitions. So first we need to calculate the Gini index when income is greater than or equal to 64,500. Then we calculate Gini index for income less than 64,500. And then we calculate a final Gini index for this split by getting a weighted average of these two Gini indexes. So let's start. Here on the top partition we have total of 11 cases and 5 belongs to case 1 and remaining 6 belongs to case 0. Here on the bottom partition we have 0 belongs to case 1 and all remaining, which is 9, belongs to case 0. Therefore, the Gini index for two subsets, Gini index when income is greater than or equal to 64.5k, 1 minus 6 over 11 to the power 2 plus 5 over 11 to the power 2, close the parentheses, which is equal to 0.4959. And Gini income and less than 64.5k is equal to 1 minus 9 over 9 to the power 2 plus 0 over 9 to the power 2, which is equal to 0. And the Gini index for this split is 11 over 20 times 0.4959 plus 9 over 20 times 0, which is equal to 0.2727. And it can be shown that split with income is equal to 64,500 produces the smallest Gini index across all possible income splits. Note that the splits at age 49 and income 64,500 produce a Gini index that is better than the original Gini index that we computed as 0.375. Now in the next video, we will start constructing a decision tree by considering the Gini index values from the two age and income splits.